Hello everyone, so my name is China, she is Josna and she is Diana and we are from group 9. So today we are going to present our project. So the name of our project is Eugenol extraction and its introduction into polymer for food packaging. So the purpose of our project is to eugenol from cinnamon, which has a natural antimicrobial property, and we are implementing the antimicrobial property to prevent food spoilage. So in this project we complete two studies. The first one is traditional and the other is the DES extraction. To find which method is better for the extraction and also find which one has the more yield. And in this project we are doing two parts. One is extraction and the other one is polymer. But we are just done with the extraction part and we are not done with the polymer because of the time. So now moving on the traditional method. So we did three methods: oxalate extraction, hydrodistillation, and microwave extraction to find which method is better. Now for DES, we prepared three DES combination: octanoic acid with menthol, choline chloride with octanoic acid, and choline chloride with oxalic acid. And also we did we mixed different salt and acid to find the best combination. And also it has a unique ability of lower melting point, because if it's separate it needs more 200 degrees Celsius to melt the solvent, and if it's together it's only needs 70 degrees Celsius to melting the solvent. So for DES, how we prepare DES? So we use these three combination and put it into the according to the molar ratio and put it into for hot plate to, and after that we grinding the cinnamon bar in the powder form and mix with the DES and put it into the hot plate. You can see in the video. After that it's put it in the warm water bath at around 40 degrees Celsius and around 2 hours. And every 30 minutes we take out the test tube and wait for the 1 minute to mix the solvent. After that we after finishing that extraction process, these centrifugations, it's around 3 minutes for 800 5000 rpm, and we got the two parts, like the one is clear and one is the dark part, and we separate the both the part, and after that we run the HPLC. Then Josna will discuss.
Okay, next one is the challenges we face throughout the project. The first one we face is that not having the chemicals at the start of the project. So we choose an alternative method, like for adding traditional method to our project to buy some time. After that, we were using the DES solvent. We want to mix together two DES solvents to combine and create. So we don't know the exact amount we need to use and to combine. So we found that from the literature and do exactly as like that. And the next one is that equipment errors. We were having equipment errors with the rotovap. It was not condensing very well and it affects our results too. Then from the HPLC we found out that we are having less presence of eugenol and we also having unknown compounds present in that one. And the next problem is that after centrifugation, as you can see, it's not that clear. The first one is having a red solution and the second one is having a clear and a dark one. So the first one is not separated. So we were searching for the solution for that, and we found out from the literature, maybe because of the density difference it doesn't separate. So this one was the best, oxalic acid and choline chloride, which didn't separate. So we ran a density experiment based on the mass by volume, and we found out from the internet the cinnamon oil is having 1 gram per milliliter, and from the experiment we got it's 0.94 gram per milliliter. So it's almost same, and we found out that's why it doesn't separate. And as you can see on the second one, there is a light and dark part. So we don't know which one is having our oil and which one is having the solvent. So we have run the FTL analysis to find out which one is having our oil. And this is the graph we got from CHCl like that, choline chloride and octanoic acid. And the red one is that the current sample we run, that is the clear part, and the blue line is the octanoic acid present. So we found that in the clear sample, octanoic acid, that is the gas, is present in the clear part. So we ran the dark part and we found out the presence of oil. But in case of methanol and octanoic acid, the light and dark parts are having both octanoic acid. So we are confused. We couldn't run that one in the HPLC because this is not allowed to run through the HPLC. But with the suggestion from Margaret, we found the dark one can be run through the HPLC. And the next one is that from the HPLC graph, you can see that the eugenol present, our compound of interest was eugenol, and the eugenol present was very less amount. In the first graph, it's like area percentage is 0.03 percentage, and the second is 0.04 percentage. That is too low. And for all the samples we ran, that is for 18 samples, we found a huge graph, huge peak in every sample. And we was confused, what is that huge one? So we found out from the literature that in cinnamon bark, 75 to 90% of the concentration is of cinnamaldehyde, and only the other part is containing eugenol, linalool, and cinnamyl acetate and other things. So extracting eugenol from cinnamon bark is impossible, like it's only a less amount of concentrate. And our project was aiming at the antimicrobial properties of eugenol, and we found out that cinnamaldehyde is also having the exact antimicrobial properties which will help in this project. And next is the statistical analysis, and Diana is going to explain that.
Okay, then the results. The first parameter that we wanted to compare was the yield of the oil. We found the yield with this equation. Is the mass of the oil obtained over the initial mass of cinnamon times 100. And we run an ANOVA test and a two-key comparison to find out which one was the best method that give us the biggest amount of oil. As you can see here, our p-value was 0.036, that is less than our alpha value, that is 0.05. Then it means that there are significant difference between the methods. And as you can see in this grouping with the two comparison, the choline chloride plus octanoic acid was the best method to have a better yield, but is not significant, statistical significant difference from Soxhlet. This one microwave, but it is from hydro. The second parameter was the area of the peak of cinnamaldehyde. We needed to do the comparison of the area because we didn't have the standard for cinnamaldehyde. Then we couldn't do the calibration curve, but the area is a good indicator of the amount of this component. Then we compare the area of the peaks, and we found out that there are statistical significant difference according to this p-value, and the hydro and the microwave were the best method to extract specifically cinnamaldehyde. And we found the same in the literature review. With these first two comparisons, we could identify that our problem with the desk was here. And actually I talk on you because Mahi, you asked the last time about the centrifuge.
Yeah, I asked you about the RPM levels.
Mm-hmm.
Yeah.
Why did you ask that? Because I don't have time.
It's my personal.
Okay, we found out the right machine. We needed at least 14,000 RPM to separate the components well and to get all the components of interest inside the oil. Our machine only reached 8,000 RPM, that it was very less, and we couldn't separate the components well, and we were having some of our component of interest inside the solvent part that we didn't analyze. Then our problem was the separation of the components to get a very good peak of cinnamaldehyde with this. As you can see here, it's almost nothing. But you can evaluate the method with those comparisons separately. You need to have one that is the final that compare all the methods in one factor. Our factor was this. We create this equation and I'm going to explain this with an example, a real example. For example, if you got 1 gram of oil, but after running the HPLC, you get a peak that is only 30% of cinnamaldehyde, then you are not getting 1 gram of cinnamaldehyde, only 0.3. But if you get with a different method, 0.5 grams of oil, and you run the HPLC and you get a peak of 90% of area, you are getting 0.45 grams of cinnamaldehyde. Then the second method is better. Apparently it's not, but if you analyze the method well, it's better. Then we create this formula that is the area of area of the peak of cinnamaldehyde multiplied by the yield of oil to combine those factors in one, and we got these results. As you can see very easily in this box plot, the Soslet was the best method. For this research, it doesn't mean that it's the best method. Only for this research, because we didn't have the right centrifugation machine. If we could separate the components with the ideal machine, probably the results were different. Joe is going to talk more about that, our future steps.
So about the future of this project, we were having some difficulties in finding DS combination. As I already mentioned, DS is a combination of 2 solvents, and one of our combination, oxalic acid and choline chloride, didn't separate while centrifugation. So it will be better to use a software to analyze which one is better for extracting. So Cosmo RS software will be helping that one. And we also found that eugenol and cinnamaldehyde is having the similar properties. So antimicrobial properties that can be implemented into polymers for food packaging system. And as Diana mentioned, our centrifugation was done at 8,500 RPM. If it was done at 13,000 RPM, it may separate our DES solvent and we will have get better results. And the next one is the conclusion. DES is a more greener and sustainable approach. DES can extract the oil and the solvent very well than the traditional method, but due to the limitations of the equipment and process, we get the lower result. And also the different extraction methods vary in yield, and we only got Soxlet extraction having higher yield. Okay, that's all, and thank you for listening.
Questions? I just want to ask what she's saying. Don't ask.
If you have a question, ask it.
Okay, I want to ask you. For instance, if I am an investor, okay? So, what do you think? Why should I
project was mainly based upon the food packaging system, but we didn't do that one because Margaret told us to avoid the second part. That was our major part because implementing the antimicrobial properties of eugenol into polymer in food packaging to avoid the spoilage. So there are a lot of interest in that one. So you can choose like if that's an interest.
So what do you think, like according to your opinion, like you just like guys interested in having better utilization of cinnamon just in for polymer industry? What about like the medicinal industry? Because the cinnamon is also has like the adding.
Yeah, it has different benefits, but this project was focused mainly on the food packaging system to implement antimicrobial.
So like for the
properties.
future implications, we could enhance
Yeah.
our perspective.
Yes, and the thing is, Maggie, that this agreement
And we are
Are
using an
cheaper.
alternative method. We are not using the traditional one here. We are using this, the deep butyric solvent, which is more greener and which can lower its melting point when mixed together. So it will help to extract more than the traditional. But upon this result, it was the opposite because of the limitations and problems.
Yeah, I got it.
So that's why.
Thank you.
and
No, not yet. I think you were having some personal grudges for me if I'm asking you questions.
no, I wanna know why did you ask that? Because it was very important for our business.
Because it was in my mind. So that's what I asked.
Okay, other questions? No? Okay, great work.